Hello, I hope you're doing well. So, today we will be talking about ownership, but not in a philosophical way, but in a Rust way. Firstly, I highly encourage you to check my blog about ownership because I explained what is ownership in details at this blog. But still, why not creating a video about it either? So, what is ownership? So, we have our memory, like stack and heap and something is pointing to something and something like that, like this is basically the memory itself. So, and I just wanted to show stack and heap, that's all. But when you are like at Java or a programming language that has a garbage collector, you do not think about memory too much or dangling problems, because if you start to point this rather than this, and if this do not have any pointer, which it doesn't have, it will be deleted, not deleted, but it will be freed. It will be freed by the garbage collector itself. And for C and C++, you are just under the God's rule. So you need to make your own decisions and you need to free. Otherwise, you will be just doing some unsafe stuff. But inside Rust, they proposed a system called ownership. So if we try to read from my own blog, we can see the rules. Each value in Rust has an owner. There can be only one owner at a time, and when owner goes out of the scope, the value will be dropped. So, like, out of the scope is a basic topic, but we can still cover it. So, you have something like println and or let x is equal to string from blah blah blah, and then you just like println x. Yeah, and same for here, and then like this is the scope, of course, like scope is this part, like just this part, and then when you go out, the x is at this point is not inside the scope. So at Rust, there will, if it is out of the scope, it will be calling a drop function, which is freeing the memory itself, which is a basic concept, right? But also this x owns the string form. What this means is this. For example, if a memory s1 points to string like this, right? Because s1 will be at the stack because it is stable and it will be always having the same memory usage, and heap will be dynamic, so s1 can change. Normally at default it's not changeable, but you can make it mutable at Rust, but it's not important. You can feel like it's changed, right? And then this is the memory part that is pointing it, and then you have s2, and then s2 will be pointing this either. So now you have two pointers pointing to the same value at the memory itself at the same point, and they don't know each other. And for example, outside of this Rust, you can change this, and S1 will be not able to sync with S2, and it will be not like understanding that S1 will be changing S2 or something like that. So something like this happens. At the same scope, if S2 starts to point this M1, then S1 will lose the ownership. So S1 will be dropped out automatically. That is the reason that it is kind of safe. I know that Rust has some unsafe stuff, like you can do unsafe, but this is not the point. The system is basic but clever. We can make an example of this. Yeah. So, for example, you are like again creating like function main and then we start to create something. Then let x is equal to string from blah blah blah. Okay, and then we said let y is equal to x, and you can think that like it didn't, like x is still available, but it's not. If you try to use x at here, println, and use like x, this will give an error. So as you can see, it gave an error. That's why I opened a playground for Rust. But it didn't give an error because of my own reason, so we will try again. So yeah, again, not my reason. Good, yeah. So this is the reason. When you look the compiler itself, borrow moved value x. So x is moved, so this string is moved to y. So x is not valid at this point. And the good thing that compiler gives a lot of reasonable errors, so you can trace the error at Rust to understand what is the code, because it gives also like recommendations, etc., but it's not the point. So as you can see that the logic is kinda basic, and this is same for the other type of systems. Like if for example S1 points to M1, or we can draw it M1 like this, and then for some reason it starts to point M2, and at this point again M1 will be automatically dropped. You don't need to manage this, so it will be freed, it will be managed. So that is a good thing. So it is working in both ways, and I liked this idea because it is, you do not need to implement a garbage collector, which can be really costly, but still you can protect your environment with this ownership system, which is really interesting. So yeah, that is my video, but of course, like, should I talk? Okay, we can talk about it. But this ownership system is not only, for example, you want to use X, but you don't want to give the ownership itself. So what you can do at that point, you can clone it, but I don't want to clone it. I don't want to show the clone because it is really costly. But these are the function examples. So you can borrow something. So imagine something like this. And if you want to understand it, you can read this part, but I will be making this more detailed, or I will maybe remove this because borrowing is another topic. Borrowing is something like this. You have something X and you give it to your friend, and then you borrow it back. X is still yours, but you gave it for a while. This borrowing system is exactly the same, but in a pro computer science system itself. So you are pointing to M1, this is you, S1, and they are pointing to you, S2. That is the goal. So borrowing ship system is this. S2 points to S1, not to M1. So if when it's finished, S2 will be not inside the scope, but you can still use this one itself inside the scope. So this code word is really good. If I write this at whiteboard, it will be a problem. So I want to show from this function, which is the same function that Rust documentation has. So you have S1 and you create an hello. And then you have a function called calculate length, which is really easy. It just calculates the length, that's all. And then returns it, right? And imagine at the previous example, if we gave S1 directly, the S1 will be now out of the scope because it will be dropped, because the ownership changed. And then the ownership changed, and now the S1 is basically, it does not exist at this point, right? So that is the problem. And when S1 does not exist, you cannot use it. So you just give the reference itself. So S gives S1 the reference, not the M1. So M1 S1 is given, S1 is the reference that is given, and then when you give the S1 as a reference, you can use the S1's functions either, because you're basically give the S1 but not the M1 itself. So S1 dot length is returned in unsigned integer type, and then you just printed it. So it is that easy. You just borrow it if you want to use it. But if you don't want to use it, and if you don't want to use the garbage collectors, then you need to make a system something like ownership and borrowing system. I don't know why, but I really liked this borrowing system too much that I just wanted to make a video about this, because it's really cool, and I just liked it. And I am reading the Rust book, and I feel like I am relearning programming again, you know. And after Rust, I will be reading a book about C++ either, and then I will be again switching to Java. I will be maybe doing them parallel, but you know, Rust is an interesting language, which I really feel interesting. It is a really interesting and a really weird programming language that I liked it. That's why I wanted to make this video, and I hope you liked it. Thanks for watching, and if you like me, you can subscribe and like, and give a comment as you wish. Thank you so much.